Okay, so we want to do the same thing with these functions. They're a little bit more complicated this time. So if we go kind of down the list, let's look at their sum first. So let's look at f plus g of x. And that is going to be 1 over x minus 1 plus square root 2x plus 1. They won't have a lot in common, and that's fine. I would at least give them a common denominator. So we're going to say times x minus 1, right? So then we end up with 1 plus x minus 1 times square root 2x plus 1 all over x minus 1. Is it pretty? No, but that's fine. And this is f plus g of x, cleaned up. Okay, next up, we want to look at their difference, which will be pretty similar overall, right? So we want to do the same thing, but subtract. So 1 over x minus 1 minus square root 2x plus 1. And so again, put it over 1, multiply by that x minus 1 common denominator. It's pretty close to the same thing, but with a negative sign in the middle. So you would end up with 1 minus x minus 1 square root 2x plus 1 all over x minus. Okay, and that would be your final answer here. This is f minus g of x. And you really should label your answers like I am right here with f minus g and all that. Okay, so multiplication is also, I would argue, pretty straightforward. We're saying what's 1 over x minus 1 times square root 2x plus 1. Again, you can make this a fraction. I don't need a common denominator. Here we just multiply straight across. So we end up with 2x plus 1 square root over x minus 1. I think in some ways the more complicated functions are actually nicer because there's less simplifying to do than if they're just nice polynomials like linear and quadratics and stuff. There's more like terms to add in those cases. And then f over g gives us, and so again, I would just write it. So 1 over x minus 1 over square root 2x plus 1, which is pretty ugly looking to start, right? I don't think anyone will argue with you on that, but you can rewrite this as the numerator, so that's a whole fraction, divided by the denominator, right? Which translates to keep changed multiplication and take the reciprocal, right? So again, multiplying straight across, we end up with 1 over x minus 1 square root 2x plus 1. Now, here's where I will caution you. It's never a good idea to leave a radical in the denominator like that. I don't know how well you remember rationalizing. And that means multiplying by that radical so that 2x plus 1, so that we have the square root of 2x plus 1 quantity squared. And then this part right here will just end up being 2x plus 1. If we're being picky, which I often am, it really should be an absolute value. So we would end up with square root 2x plus 1 over x minus 1 times absolute 2x plus 1. Depending on how, again, picky, whatever it is you're working on is with those absolute values or not. Again, we're trying to guarantee radicals are positive. That's how we do it because there's a variable there. If you're working on something that's less concerned with that absolute value, then I would definitely multiply out the x minus 1 and the 2x plus 1. Okay? The last thing that we're asked to find is the domain of all of these functions, which is lovely. Okay? So if you remember our domain we're interested in, what's the individual domain of f of x, which was 1 over x minus 1, and what's the domain of g of x, which is square root 2x plus 1. Make sure I have that right. Yes. So for each individual part, finding their domain, well, this is a fraction, right? Our first one's a fraction, and this cannot be equal to 0, which means we cannot have x is equal to 1. So f's domain is all real numbers except for 1. So there's an open circle here at 1. Everyone else is shaded in. Okay. G of x, on the other hand, it's a radical, so we take the radicand, the inside, and we set it greater than or equal to 0. So that's 2x greater than or equal to -1, and x greater than or equal to -1/2. So that's back here a little ways, and that's greater than or equal to, so -1/2. So that is a bracket, and I should give it its own picture. So if we draw that out, I don't want it to get too messy. -1/2. And so we're shading out this way. So the domain of our first three functions, the sum, the difference, the product, is going to be the intersection of these two. So what do these two have in common? Well, everything from -1/2 on, and do you see -1/2 is included in both the pink and in the blue? So we include this -1/2, right? Through it, I have to skip over 1, but everything between counts and everything after counts. And that's because this is an open circle up here. Okay, so this in interval notation gives us bracket -1/2 to 1 parenthesis union 1 to infinity. This is our domain of f plus g, f minus g, and f times g. To go the extra mile for our division, we need to make sure that we are not equal to 0 in this denominator function right here. So again, we build off of the work we just did. We don't have to throw it away. It's still useful. We just also say the denominator cannot be 0. So if we're building off of this purple picture right here, our denominator function was square root 2x plus 1, and this cannot be 0, right? So if a square root 0, then that means the radicand has to be 0, right? Not equal to 0. You move the 1 over, and you divide, which means that's the only value we have to remove. Everything else is exactly the same. And essentially what that means is instead of having a bracket right here, like we do on the earlier question, the domain of f over g is the same thing, but with a parenthesis there. Okay, that's it for this group. There's one more, and then you can move on to composite functions.